Any doubts in up to till now on the distribution board, distribution of LVAC as well as DC? Architecture. This is the architecture.
Please explain interlockings. I couldn't understand.
Yeah. So, let me show this. So I'm having a transformer here and a breaker, and this is a one more transformer. This transformer, 3 breakers are there, and I'm having a DG set here. This DG set for our project, for our explanation, this it won't come into the picture because it's a manual operation. No need to discuss this. So we are providing some interlock between these breakers, either interlock, or either electrical interlock or mechanical interlock, or if you want, you can place both. So what is electrical interlock? What is mechanical interlock? Electrical interlock is generally, I will take the signal. For every breaker, there are NO, NC contacts. A NO contact and a NC contact. NO contact and NC contact. So, and this breaker is also having a NO contact and NC contact. This breaker is also having NO contact and NC contact. Now, I want to, what is my, what is aim here? See, I have to close only 2 breakers at any point of time. Suppose if I want to close this breaker, let's see A, B, C. These are the 3 breaker names. If I want to close the A breaker, what are the conditions to be satisfied? If I want to close the A breaker, C breaker, if I want to close the A breaker, either C breaker should be closed or B breaker should be, sorry, C breaker or B breaker should be, any one of the breaker should be in open condition. Should be in the open condition. Right? See, if I want to close the A breaker, the C breaker or B breaker, either one of the breakers should be in open position. Like, if suppose, if I am talking 1, 0, 1 for close, 0 for the open, if this 1 and if this 0 should have gives me result of 1. And if should be 0 and it should be 1, then also it should give the result of 1. If both zeros and 0, if both 1s, then also it should be 0. So what is the logic here? OR gate. So I have to place the OR signal or implement the OR gate between this C and B. Like, I will take the status of the C, this one, and I will take the status of this NO or NC, whatever it may be, and I will create an OR gate, and this signal I will use to the this one. If any one signal will comes into this, means if the flag rises to the 1, so this breaker will be closed. So this can be done digitally, or you can develop this with hard wiring. You can develop with this with the hard wiring also. So you can do this. So that when you are doing with the hard wiring, it seems that hardware electrical interlock. If you are doing with a some digital, if you are taking these signals inside the computer, and if you are doing that, if it is 1, if it is 0, then on the breaker. If you are giving some signals in that with respect to the digital platform, then it would be a soft logics. This is the hardware logic, this is the soft logics. But both are electrical interlocks. Then what is the mechanical interlock? Mechanical interlock is, if you place the, suppose when I starting this one, I will purchase 2 keys. I am having only 2 keys for 3 breakers. If I insert the key, then only I can operate this breaker on or off. And if I insert the key to this, then only I can off on or off. If there is a no key, I cannot on or off this breaker. This is a kind of mechanical interlock, which is coupled to that fixed contact or moving contacts directly with some mechanical interconnection. Suppose I am having 2 keys, I am placing here. So I placed the 2 keys and I on this breaker and this breaker. And I off this breaker. So these are all running. Suppose tomorrow this transformer has failed and this breaker was opened. So I will remove this key. This breaker was opened. I will remove this key and I will place the key here and I will close this. So again, this now this breaker and this breaker is in closed position. So this is a mechanical way of interlocking. So mechanical interlocking, electrical interlocking. As this is a low voltage system, a 415 volts distribution, mostly we prefer a mechanical interlocking. Or maximum, in up to some extent, we will go for hardware electrical interlocking. Soft logics will not be required because it's for a low voltage system. If you want to develop a soft logic, again, you have to purchase some intelligent electronic device, which we will call a BCPU or some controller kind of thing. It's a costume more. Understood? And this interlock concept chapter is there in our coming classes. In detail, I will explain them. But for time being, I given you a brief idea on this. Clear?
Clear.
Yeah. So this is about the LVAC architecture thing. So LVAC, if you see in our LVAC single line diagram, we are having one transformer, auxiliary transformer, 2 number of auxiliary transformers, and 1 DG set and battery charger, as well as a battery bank. So these are the things we are having for this system. Now we have to size this auxiliary transformer, DG set, and battery charger and battery bank. Luckily, the auxiliary transformer and DG set sizing are same. The auxiliary transformer and DG set sizing are same. Both are same. So we are talking on auxiliary transformer or DG set sizing. That is a one exercise we have to do. Other one is battery charger and battery bank sizing. So these are the 2 exercises we have to do. So after this, what else will be there in the LVAC? MCBs. We have to discuss on various types of MCBs or MCCBs, types in the sense with respect to the curve. We are having so many curves for the MCBs. See, generally, if I ask you to place, suppose my load is 30 amps or 20 amps, what you will say? Oh, I will place some 63 amps MCB. For which application? 63 amps MCB is you can place the same MCB you cannot place for motor loads. The same MCB cannot be applicable for electronic equipment, even though the load ratings, everything are same. Because we have to differentiate that with respect to the curve. Curve in the sense in MCB and MCCBs, the TCC curve, overcurrent capability, overcurrent curve, which will operate with respect to the overcurrent, and thermal curves, they are fixed in the MCBs. So you have to select the curve based on your application that we will discuss. So, and we have to discuss the cable sizing. By this, we will complete our LVAC module. So what are the things we are to discussing? Auxiliary transformer or DC set sizing, battery bank and battery bank size, battery charger sizing, MCB selection, and the fourth one is the cable selection. So today, let's start with auxiliary transformer or DC set sizing. So before going to this, first let's discuss about some loads. What are the loads in the system?